It is taller than the Empire State Building. It weighs 1.2 million tons when loaded for transport. It sits on the floor of the North Sea in 303 meters of water, and the elevator inside one of its legs takes more than 9 minutes to travel from the platform deck down to the seabed. In 1995, the people of Norway watched it move on live television as a convoy of tugboats towed it 200 kilometers across open water in a 7-day journey that stopped traffic, drew crowds to cliff tops and coastlines, and entered the national memory as one of the most extraordinary things the country had ever built. It is the tallest structure ever moved by human beings in the history of civilization. And most people outside Norway have never heard of it. This is Troll A, the largest object ever relocated on the surface of the Earth. A concrete structure 472 meters tall, 369 meters of which sits permanently below the waterline, rooted to the North Sea seabed by its own weight and by vacuum anchors bored into the ocean floor. A platform that holds the distinction of not just being built, but being built somewhere else and then moved, intact, in one piece, to a location where it would sit for the rest of its operational life, producing the gas that heats homes across Europe. And the reason it had to be this size, this weight, and this technically extraordinary is a number that explains everything. The Troll gas field contains approximately 1,437 billion standard cubic meters of recoverable gas. That is 40% of Norway's entire gas reserves. It is one of the largest natural gas fields ever discovered in the North Sea. And it sits beneath 303 meters of water, at a depth that made every conventional offshore platform concept useless. The Troll field was discovered in 1979. Commercial viability was declared in 1983. And the engineers who looked at the water depth and the reservoir depth and the volume of gas that needed to be extracted sat down with a design problem that had no existing solution. The gas lies 1,400 meters below the North Sea seabed. To reach it from a fixed platform, the platform has to stand in 303 meters of water. In 1983, no structure built by the offshore industry had ever operated in water that deep on a permanent basis. The previous record holders were modest by comparison. What Troll required was not an incremental improvement on what existed. It was a different category of structure entirely. The answer was Condep, concrete deep water structure, a Norwegian engineering concept developed through the 1970s that proposed using reinforced concrete rather than steel as the primary structural material for deep water offshore platforms. Steel structures at extreme depth face enormous challenges with corrosion, with the weight of the steel itself, and with the fatigue loading from wave action acting on a structure over decades of service. Concrete, by contrast, is chemically stable in seawater. Its mass provides inherent stability against wave forces, and a concrete gravity-based structure requires no anchoring to the seabed beyond its own weight. The Condep concept that had been used for earlier Norwegian platforms in shallower water. Troll A would push it to its absolute limit. The construction contract was awarded to Norwegian contractors in March 1991. What followed over the next 4 years was a construction sequence that had no parallel in the offshore industry. The base of the platform, the gravity-based structure that would eventually sit on the seabed, was built first. 19 cylindrical concrete cells arranged in a ring configuration, forming the foundation and the buoyancy tank that would allow the structure to float during transit. This work began in a dry dock at the Hinnevogen Yard in Stavanger. 245,000 cubic meters of reinforced concrete poured and shaped into a base that would eventually have to bear the weight of the entire structure through decades of North Sea weather. Then the legs were built. 4 massive concrete legs, each one rising from the base to a height that would eventually place the deck above the surface of the North Sea. The legs are not solid concrete. They are hollow cylinders with walls more than 1 meter thick, built by a process called slip forming. In slip forming, the concrete formwork moves continuously upward as concrete is poured below it, hardening in place as the form rises. The operation never stops. The concrete is poured in a continuous flow, 20 minutes per 5 centimeters laid. The formwork climbing the growing structure around the clock, day and night, until the leg reaches its full height. Stop the process and you get a cold joint, a weakness at the point where old concrete meets new. The legs of Troll A were built without cold joints because the slip-forming operation never stopped from beginning to end. The geometry of each leg is not a simple cylinder. It is a mathematically precise composite of several conical sections that flare outward to greater diameters at both the top and the bottom. The wider base distributes the load across the foundation. The wider top supports the deck above. The narrower section in the water column minimizes the surface area exposed to wave forces and reduces the hydrodynamic loading that the North Sea delivers continuously against any structure in its path. Every dimension of the leg profile was calculated against the specific wave climate, water depth, and structural loading that Troll A would experience for its entire service life. The deck of the platform, the processing modules, the gas compression equipment, the living quarters, the cranes, and all the mechanical and electrical systems of a full offshore production facility was fabricated separately at Akerstord. While the concrete base and legs were rising from the dry dock at Vats, the topsides were taking shape on land to be mated with the concrete structure in a controlled operation before the tow to the field. By 1995, the base structure had been towed from the original construction dock to the deep fjord at Vats in Rogaland, where the water was deep enough to allow the structure to be floated to the depth required for the deck mating operation. The top sides were brought out on a barge and lowered onto the top of the partially submerged concrete structure. The mating operation joined a concrete substructure that had been built in one location with a steel top sides that had been built in another, in an operation that required both components to be positioned with precision while floating in the waters of a Norwegian fjord. Then came the tow. May 10, 1995. The Troll A platform left Vats under tow. The completed structure, 472 meters tall from its base to the top of its deck, was floating with approximately 170 meters visible above the waterline and the remaining 302 meters submerged below. It was being moved intact, in one piece, as a single object. Ballasted with seawater in its hollow legs and foundation cells to keep it stable during the transit, it weighed 1.2 million tons under tow. Nothing that heavy had ever been moved across the surface of the Earth before. Nothing that tall had ever been moved while floating. The convoy of tugboats held it on course as it moved through Norwegian coastal waters, around headlands, and out into the open water of the North Sea. The people of Norway watched it on television. They drove to cliff tops and coastal roads to see it pass in person. A 472-meter structure, moving slowly through the waters of a country that had built it, understood what it was looking at. The tow took 7 days. On May 17, 1995, the Troll A platform reached its location in the Troll Field, 80 kilometers northwest of Bergen. Then it had to be sunk. The engineers opened valves in the foundation cells, allowing the seawater ballast to flood inward in a controlled sequence. The structure descended slowly, millimeter by millimeter, in terms of the precision required to place it correctly on the seabed. As it descended, divers monitored the base. Engineers on the surface watched the instrumentation that tracked the platform's position, tilt, and rate of descent. Any deviation from the planned touchdown point would have compromised the foundation geometry. The Troll A platform settled onto the North Sea floor in 303 meters of water on May 17, 1995. By May 19th, it had penetrated 36 meters into the seabed soil under its own weight. It is held in place by that weight and by groups of vacuum anchors, 6 40-meter-tall suction piles per leg position that lock into the seabed mud and create a grip that no wave loading the North Sea produces can overcome. No mooring lines, no anchors of the conventional type. The structure simply sits there, too heavy to move. Inside one of the legs is the elevator, the leg that carries the gas import and export risers, the pipes that connect the wellheads on the seabed to the processing equipment above, is accessible by an internal elevator that descends from the deck through 303 meters of concrete to the seabed level. The journey takes more than 9 minutes. 9 minutes inside the leg of a concrete structure, descending through water pressure that increases continuously toward the bottom. The workers who service the equipment at seabed level enter a working environment that has no equivalent in any other industrial facility on Earth. In 2006, Equinor celebrated 10 years of troll gas production with a concert inside one of the hollow legs of the platform. Katie Melua performed for the crew at 303 meters below sea level. The Guinness Book of Records confirmed it as the world's deepest underwater concert, a distinction nobody had previously thought to seek, because nobody had previously had a hollow concrete leg at that depth to hold it in. Troll A produces gas from the Troll East Reservoir, which holds approximately 2/3 of the total field gas reserves. The gas comes up through the wells, is processed on the platform, and flows to shore through a pipeline to the Kolsnes terminal near Bergen, 65 kilometers to the east. From Kolsnes, it enters the European gas network. The platform has been powered from shore since 2005 via an HVDC power cable, the world's first use of high-voltage direct current technology to power an offshore platform from land. Two 68-kilometer submarine cables carry 84 megawatts, later expanded to 184 megawatts, from the Kolsnes static inverter plant to the platform. Shore power eliminated the diesel generators that would otherwise burn fuel on the platform continuously, reducing emissions and operating costs simultaneously. When a grid emergency arises on shore, the platform is automatically disconnected from shore power and switches to its own generation. The system has worked without failure since commissioning. As the reservoir pressure has dropped over decades of production, the platform has been progressively upgraded with additional compression equipment. New modules were added in 2010 and 2013, containing additional compressors and expanded living quarters and control room facilities. The increased power demand of those compressors required additional shore power cables. The platform that was built to extract gas from a full reservoir is now being continuously adapted to extract it from a depleted one, squeezing out the production that the economics of European gas supply justify year after year in water that most of the world's offshore industry would have considered inaccessible in 1983. 472 meters, 303 meters of water, 1.2 million tons moved across the surface of the sea, 40% of Norway's gas reserves, one elevator, 9 minutes to the bottom. The tallest structure ever moved by humans, parked on the North Sea floor and still producing 30 years after it arrived. The gap between what exists and what is needed has been the engine of every structure humans have ever built. Fill the gap. That is the whole job. That is all it has ever been. Like, share, and subscribe for more.